right, Susan's a good friend of mine. She's on our operating committee. Occupation, mechanical engineer, correct? And doing some wonderful things over at Stark State. And this is a pretty exciting session. Yes? You know what? I did not print off extras, but why don't you guys share, and then I will make sure I bring some extras next session. Okay? All right. Thank you. Okay. With that, I'm going to turn it over to Ms. Shearer.
So I'm going to be talking about mechanical engineering a little bit and engineering as a whole. And then I actually brought some kits so we could do a little fuel cell kind of solar experiment later if time allows. And if not, we can do it during the exchange period. So I wanted to just verify how much time do we have?
Now we're in 20 minutes.
Oh, we've got plenty of time then. So we'll definitely have time for an experiment then. And hopefully you didn't use it. All right, yeah. So you've met with a few engineers already. So you know that in fact, the definition by Webster's of an engineer is that engineering is the application of math and science by which the properties of matter and the source of energy in nature are made useful to people. Now, in fact, this is a very apropos definition because today I'm also going to be talking to you a bit about careers in the energy sector. So it's great that it talks about sources of energy right in the main definition of engineering. So really, engineers come in many, many different forms. As you've already seen, I think you've met at least 4 or 5 engineers already through the course of your studies here so far. But above all, what you'll find and what you've seen is engineers are really problem solvers who really make things and processes better. And if we can't fix it, we'll create something new. So that's another aspect of engineering. And the salaries, quite frankly, for those with a bachelor's of science in engineering tend to be extremely good. My career has been just an excellent process of continuous improvement. I have lived in 8 states. I have visited 5 of the 7 continents. It's been quite an exciting career. So I can say that engineering and particularly the bearing industry has been very, very good to me. And what you can also see is that depending on your level of education, and this is actually true of many different fields of study, the higher your level of education, typically the higher your wages are going to be. And the major disciplines of engineering, of course, are mechanical, electrical, chemical, civil, and industrial. But in fact, the engineering fields can cross into so many different areas, such as automotive, aerospace, agriculture, biomedical, computers, environmental materials, nuclear robotics, and safety, just to mention a few, but there really are hundreds of different ones. So today, I'm going to focus a little bit more on mechanical and mechanical electrical related to my own experience, both in the past and currently. So this is where what I'd like to do first is to play the Career Day video because it was created by Timken and it shows very clearly many of the different aspects of engineering from someone who would be in the bearing industry. So let's go ahead and if for some reason the sound doesn't play, I do have speakers. I'll go ahead. which is the internet connection? Or is there an internet connection?
Click Firefox on the phone. Just click one of the buttons.
Oh, no, it says I'm not connected. Can we play this from the other computer? If I unplug it?
If you have HDMI.
The problem is I couldn't open PowerPoint because the PowerPoint's expired on this computer. So if you could switch screens, if you could pull up YouTube.
Sign that again. Yeah. That's about all I know how to do. Bruce, your friend, the IT guy, we need him.
Yeah, and actually what you need to
It's
do also is
more
to
evident
buy a
than-
subscription to, yeah.
Sitting there going, boy, I wish he was in the room. Watch next week? Good, okay. I'll be there.
Where's YouTube?
And so basically my mom
Good sound.
either gives kids shots or she gives them medicine to make them better.
Excellent job, class. So what did you bring to share with us today?
The world. It looks like a marble.
Your dad makes marbles?
My dad works for Timken.
What is a Timken?
That's a Timken.
How cool was that?
So that gave you a good view of where bearings are used and also a little snapshot of why engineering is so important to an industry. If it wasn't for the engineers, that helicopter wouldn't stay up in the sky. And that rocket would not have made it up into space. It took a lot of other fields of study to succeed in that accomplishment as well. They all work together. But quite frankly, without the engineers, it wouldn't have happened in the first place. So it is so important. So I'm going to be talking a little bit now about the specific field of energy and as it relates to some of the curriculum that we have at Stark State College. As you saw from my bio, I'm the Director of Fuel Cell and Alternative Energy Technologies, and so that is my current role. What we saw from my past record is I've also had a very long career in the bearing industry, globally. So my master's is from the Rotterdam School of Management in the Netherlands. That was a lot of fun, being able to work and live overseas and being able to manage a group of international employees from all different countries, testing and developing new products in the bearing industry. That was my career with SKF. When I came to Timken then, I moved on into product management and then the management of the change, management of change group, which is so important. If you can imagine that you have one product being made in as many as 6 different factories, and that product could go into a Ford, a Chrysler, or GM vehicle that's produced in any one of those countries, and that product has to react and live and be sustained and strong and meet the same warranty criteria no matter where that product is made. As well, every bearing has its own little signature. So if the product has a little bit of vibration in it, produced in one factory, the motor that bearing is in is going to have a different signature. So this is why standards and control and uniformity across the globe is so important. So that's why I was part of a global management of change initiative to ensure that if one factory that had the design control of a particular product was making a change, that every other division that was related to that product would know about that change and everything would be coordinated so that they wouldn't have a tremendous amount of excess products that would be obsolete by the time the change was initiated, or certain components of that product would become obsolete and scrapped as that change was initiated. So managing changes is pretty important. But now I'll come back to my current role in Stark State College. So I am the Director of Fuel Cell and Alternative Energy Technologies. So within that role, we have supported many, many different initiatives. The largest being, of course, if you've been on campus, the building of the LG Fuel Cell Systems Prototyping Center. Today I'm going to walk you through a little bit about what that was about, and what that company does, and what kind of opportunities are there for engineers. Another large initiative that I've been part of for the last 5 years is the NSF Great Lakes Fuel Cell Education Partnership. This partnership is a collaboration among 6 different schools in 11 states to develop the engineering curriculum for fuel cells and electrochemical processes so that the engineers of today can meet the needs of industry tomorrow. Other projects that we've been engaged in are within the Department of Energy, the Department of Defense, and then, of course, the Wind Energy Center, the Timken Technology Test Center that you'll see up near the airport when you're driving up Frank Road, and ShaleNet, which is in the oil and gas industry. So our current profile in energy today is such that you can see our supplies come predominantly from oil and coal and natural gas, certain percentage of nuclear. Then in the renewable energies, we have the groupings of hydro, wind, solar, biomass, and geothermal. Now, this is America's profile as a whole. If you look at the Ohio profile, it's a bit different. You see a lot more coal in that mix. And what you also see in our forecasting of the energy profile is that the demand for energy is ever increasing. And the problem is, the challenge is that we want to be less dependent on foreign oils, but at the same time, our demand profile is increasing. And we also know that ultimately, fossil fuels are actually finite. And we're consuming them at a rate that is greater than the Earth is restoring them. So we need to look at alternative energies. And fuel cell technology is one such means of conservation. Now, if we look at the Ohio profile directly, you see coal-fired burning plants stand out dramatically as far as what is the where's our energy coming from here in Ohio. Next, you'll see the natural gas-fired generation, and then thirdly, the nuclear. Those are the kind of the big three in Ohio regarding energy production. So overall, our generation actually shifted a bit from that earlier slide, which I think was from 2009. 2011, we're at 77% from coal, 11% from nuclear, and 9% from natural gas. And I have to say, as you all know, we're in the mecca of natural gas, so you're going to see that number increasing. One of the initiatives in the state that's driving careers in alternative energy, as well as improving our profile of our energy generation, is the initiative in the state that will be at 25 by 25. You'll be hearing a lot more about this during the next years, but this is actually what is helping to drive as well incentives for industry to move towards renewable and advanced energies. So the plan is that by the year 2025, 12.5% of our energy generation is going to be from renewable energies, and 25% or 12.5% would be from the advanced energies. So this will ultimately lead to a better use of our resources, less use of the resources that cause other problems such as emissions and so forth. And it will also give us much more security because we'll be moving from centralized large plants transmitting power over long distances with losses to decentralized resources that are smaller plants serving a network of areas within the state. Because of these changes, there's tremendous new job opportunities for all of you as you go on to your engineering degrees or IT degrees or other types of degrees related to the opportunities that will be coming in this power industry. Yeah.
Excuse me, I'm familiar with most of the terms on this slide except for cogen. What does that stand for? Cogeneration is
when you actually have two processes working at the same time. You know, I can pull specific references for you to show you specific examples.
All right.
There's not really time to go into that
That's
right
fine.
now, but we will. I can
Okay.
send you more details on that.
Sure.
As a little bit of an example, we have systems that are combined heat and power. So you can have systems that are actually performing two energy tasks at the same time.
Oh, so one's sapping up like the heat entropy of the other or something like that.
Yeah.
Okay.
So you can actually and when I get to the LG fuel cell system, I'm going to actually explain such a process as
Okay.
that, where you have a high temperature process that yields heat in the process that then is reused within the process, or it can also be used for other productive means. So now I'd like to talk about some of the different areas of the campus where we're training and developing the engineering in different fields. So this is the picture of the Technology Test Center that's at the corner of Schuffel and Frank. How many of you have driven by that? Anybody notice it? Okay. It's
Yeah,
really...
How many of you have been to the Stark State campus? Raise your hand.
Okay. How many of you have been in the fuel cell center? Okay, handful. Okay. Yeah, I won't be going inside that center, but I'll actually be telling you more about that center as we go forward. So at the Technology Test Center, it's a collaboration with Timken and Stark State. And at the upper level, which you see from the parking lot, we have a beautiful lab and classroom and conference room for holding classes and also being able to have meetings and so forth. And in the lower floor of that building, Timken has a MTS machine which can do dynamic loading situations on the main bearings for large wind turbines. Wind turbines in the size range of producing 2.5 to 3 megawatt plus power. So it's a very large machine. And the whole building actually was built around that machine. And a couple of weeks ago, or maybe it was a month ago, you saw some of the large construction projects that one of the engineers that presented was a part of. The infrastructure for this building was that much of an engineering feat as well, because they had to put in the supports of what would be just like building a 3 to 10 megawatt scale wind turbine. So the rebar and the construction for the support of that machine was an engineering feat in itself. And the reason why all of that rebar and construction was necessary was that that machine had to be totally separate from the whole building. Because otherwise, when you put a load on something, you have an equal and opposite reaction load. Which means that all of those loads on that machine have to be taken up to the ground and separate from the building. Otherwise, the building would fall down, being cycled and cycled so many times. So this was really quite an engineering feat. If you go to the Stark State website, you can actually see pictures of the construction from the start to the finish. But we're not talking about construction today, so I'm going to move on. Now, this is why that machine was built. If you look at the sizes of wind turbines over time, you see a marked increase in the size of those wind turbines. And in fact, when you get above a 2.5 megawatt scale wind turbine, that's when you start to see tapered roller bearings as the main bearings in the turbine. And that's why Timken was very interested in developing the best bearing in the world for this application. So this picture kind of shows you what those different types of bearings are depending on where you're at. So in the smaller range, below 2.5 megawatts, you see a spherical roller bearing as the main bearing. And a spherical roller bearing has rollers that look like little barrels. And the raceway is curved over those curved rollers. And the reason why that bearing is popular in those size ranges is that one of the advantages of a spherical roller bearing is that it can take dynamic misalignment. So the bearing can roll, but also take those shifts that occur because of the loading and the variability that happens when you can imagine the gusts of the wind is changing. So that's why spherical roller bearings are so popular in the lower sizes. But it's a blessing and a curse that it can do both, take the loads and be dynamically misaligned, in that whenever something misaligns as it's rotating, you have a little bit of sliding. And because of that sliding, you have wear between the two components. And so for that reason, when you get above the 2.5 megawatt, you start to see loads which by this type of bearing just can't handle that kind of loading. So you need to take those loads in a better way and assure as best as possible the true rolling, because with true rolling then you have the lubrication between the meeting components, and the bearings can live that much longer. And of course these turbine, the nacelle of the turbine can be 325 feet in the air. So you certainly don't want those bearings to fail and have to come in with a helicopter and some very incredible wind cowboys to come in to disassemble the motor in the air and bring it out, or worse, have to remove the whole nacelle, carry it over, bring it to the ground, and then do maintenance. It's not very economical. So you want those bearings to go, to run for 30 years without any failures. So you can imagine that not only is it important to have the right product that takes engineering know-how to understand all of the loads and the situations that that bearing is going to see, but also the right preventive and planned maintenance on that product so that it's not going to fail after the 5th year because you forgot to grease it, you forgot to lubricate the components. No, it's very important. Now this is a picture of some of the types of equipment that we have in that technology test center. You see on the left is a wind turbine simulation machine. In fact, it's basically a robot that looks like a wind turbine. Because of course we are not driving the system by the wind. Instead, we're driving it by power so that we can see how all the components work. So if you put energy into a motor and drive it, like for instance from the wind, it becomes a generator. If you take energy from the motor, then it's basically the motor. So here we are basically running a wind turbine that is a motor because we can't have the wind to be able to rotate that on the inside, but we can simulate all the components and understand the process. So here, instead of generating energy, we're actually using energy, but at least you get a good idea of all the components that go into the construction, the gearing, the yaw mechanisms and pitches for the blades and so forth. And on the next picture on the right is a general purpose electrical trainer, because in the wind turbine industry, it's critical that the technicians understand alternating current, direct current, and all of the different switches and controls that are related to transmitting and generating energy. So I told you that I'd speak a little bit about the fuel cell center. How many of you, or does anyone here know what a fuel cell is? Yeah. Jordan, do you want to?
Isn't it kind of like it harnesses like hydrogen? It's kind of an energy source.
It can. A fuel cell is a means of producing power electrochemically. So we'll get a chance to do some hands-on experiments as I finish the presentation. Now, our relationship in the fuel cell industry actually dates back to 2003. Some of you have been to the prototyping center and the fuel cell center. What you might not know, if you haven't been to LG Fuel Cell Systems, is that attached to our fuel cell lab is a whole factory, a prototyping center that's actually building a 1 megawatt scale solid oxide fuel cell system. And I'm going to be showing you in a little bit exactly what a fuel cell system is and how it works and how the different technologies work. So this relationship started back in 2003. And at that time, the state realized that if we do not go forward with supporting emerging technologies to improve our energy efficiency, then we are really going to have a huge problem in the state. Because we are a huge manufacturing state. We use a lot of energy. And because we use a lot of energy, we emit a lot of NOx and SOx and CO2 or carbon monoxide and so forth. So we really have to be careful to preserve our environment. So what happened was the state said, okay, we're going to fund and support public-private partnerships. So we built a prototyping center that was basically an incubator for new companies to develop their technologies so that in the future we would have a next generation of power generation.
Did the state work with any other colleges?
All over the states, yeah, yeah. So it is really awesome. So this was the first center that was built. It was purely a incubator. Stark State didn't have any space inside this building. It was all companies. And fortunate for us, the first two companies to occupy that space were the engineers from Rolls-Royce and Sofco. And very quickly, the two companies realized, wow, together, we can change the world. Seriously. Because one had a fuel processing expertise that was really incredible. And one had a fuel cell technology that was just as incredible. So they decided, hey, Stark State, we don't want you to let anybody else come into these bays. We want to lock the doors. We're becoming one. And Rolls-Royce bought Sofco. And that's the same Rolls-Royce that makes jet engines. The same Rolls-Royce's name that's on vehicles, but they're not really, Rolls-Royce really isn't in the vehicle business. They sold that brand, but they're really known for their jet engines and propulsion. So the next step was, okay, now we need to build a prototyping center. So we have this great technology that we have tested and verified in a smaller scale. Now we need to increase that. Now, as I'm talking about this, do you kind of hear a lot of engineers in your mind? There's a lot of engineers that made this all happen. So what the next expansion was in 2009, we actually added 23,000 square feet so that they could put in their prototyping center.
Is the project like given to one company and then like that company calls other people like to come and help them work it?
Actually, in this case, this was developed by the company itself.
Okay.
So the reason why they needed to expand is that Rolls-Royce actually had centers for fuel cell development in England and Singapore. But they realized that this technology in marriage with Sofco was really just revolutionary. So they shut down, for the most part, their operations in England and in Singapore, and they moved all of the test equipment from those locations to North Canton, Ohio, and installed it in this new building that was built. And then made this the world headquarters for Rolls-Royce fuel cell systems. Now the benefit to Stark State in this expansion was, you see the little green area in the corner? That's when our fuel cell lab was built. Because they also realized that we have just this number of people that know about fuel cells, but we need the next generation of engineers because we're growing and nobody knows anything about fuel cells for the most part. Even though they've been out in the market for over 50 years, this technology was brand new. So we really needed to develop curriculum and expand. And this is where the project that I am on kind of started. There was a pre-project before my NSF Great Lakes Fuel Cell Education Partnership that helped to develop the first curriculum for these engineers that then were interns at Rolls-Royce, and many of them now are full-time employees at Rolls-Royce. So then they realized, okay, this technology has been tested out. It really is proving successful. We're getting closer to commercialization. We need 30 more engineers. We need to expand. We also need capital. We need an integrator partner. So what happened? LG partnered with Rolls-Royce, and you now have LG Fuel Cell Systems Incorporated, which is 49% owned by Rolls-Royce and 51% owned by LG. The same LG that you might see on your television, on your dishwasher, on your washing machine, on all kinds of different electronic components. So, can you imagine what sort of expertise LG brought to the table? Looking back to the slides of the kinds of engineering jobs that there's so many different types. Supply chain, logistics, manufacturing. So it really was a good marriage. And also, another increase in opportunities for engineering. So, up in the corner, you see they added, surrounded by yellow, the engineering offices for that commercialization team. That's the team that is designing the overall package for the system that has been developed. They're doing the feasibilities on manufacturability and repeatability. Because while you can create something and test it and verify it, now you're going to need to make 100 of these. And you've got to make sure that the first one is as good as the 100th one, and that the components are perfect for each one. So it really takes not just a handful of engineers, but a little bit of a city, in a way, a village. And the benefit to this expansion was also that Stark State has another lab now, another 1,000 square feet, to focus on the renewable energy and particularly solar energy and electrical training. So the total facility now is 60,000 square feet. And the kinds of positions that are in this building of LG Fuel Cell Systems Inc. are design engineers, manufacturing technicians, controls engineers, test operators. Yeah.
With your facilities being so big, how do you keep track of the energy is supposed to protect the environment, but the things that live in the environment are being misplaced too when you build your facilities because they're so massive. And if you guys want to do this and it works, then everybody would want to do it. Which would mean there'd be hundreds of facilities.
Yeah, you have to, you're mixing different technologies right now. Yes, sometimes birds and bats do get killed by wind turbines. Did you know that more birds and bats get killed by windows than they do by wind turbines? When wind turbines are placed, a tremendous study is done on migratory paths as well as habitats to make that impact as low as possible on the environment. Now, frankly, some of the early farms, unfortunately, did not do that. And where wind energy got a really huge egg in the face, and it took them back quite a ways, is one of the largest wind farms in the beginning actually was put right in the center of a migratory path, and it was a bloodbath. It was really bad. They learned a lot from that, and today it won't happen. So, for example, we will not have a wind turbine at the corner of Schuylkill and Frank. Not because of the airport, because the clearances are okay. But there's a special protected species of applebat that lives in the woods behind the facility. And we will not take the risk of hurting that habitat for that applebat, or killing that applebat. So we do take those things into consideration. Now what you'll see is that the system that LG is producing isn't that big. It isn't invasive to the environment. And actually it protects the environment over coal-fired burning plants.
Regardless, it's the environmental damage done by these are negligible compared to coal and natural gas.
Exactly, exactly. So this picture gives you an idea of the size and scale of a 1 megawatt fuel cell system. It is basically the size of a tractor trailer. It's not a big generation plant like you're used to seeing. So it really does actually minimize the footprint and minimize the impact on the environment. And even better, it doesn't have the NOx and SOx emissions. They're zero. Yes, there are still some carbon monoxide exhaust, but not near what any other power generation has. And I won't go into detail on the particular system, but if anybody wants to talk about that separately, I will. So in order to develop those future fuel cell engineers and technicians, Stark State has fuel cell degrees and certificates. The Mechanical Engineering Technology Associate's degree with a fuel cell major is a tagged curriculum. And many of the engineers that have taken this curriculum have gone on now, and I know of at least 4 engineers at LG that started as students at Stark State, that interned, engineering internships while they were going to school, went on to Akron U or other colleges and have completed their engineering degrees and are now full-time employees at LG. I know actually of 11 of our students that are full-time employees that didn't necessarily intern with LG, but because of their fuel cell knowledge and because of their background are now full-time employees. We also have a 1-year certificate that's focused on the fuel cell technology for either an engineer who wants to come back to get that special fuel cell knowledge, or a engineering technician that would like to be able to be a test technician. And we have a few individuals that are full-time employees at LG now that went through this program and became fuel cell technicians. And then we have the Fuel Cell Certificate of Competency. This is predominantly what those returning engineers come back to take, because they already have all of the curriculum under their belt of what the 1-year certificate would have. So they'll come back in just for a specific class or 2 focused in the fuel cell area. We also have other courses in the renewable alternative energy curriculum that I had mentioned before. So we have a sustainable alternative wind energy 1-year certificate, and then we have a wind turbine maintenance 1-year certificate, and we have electrical maintenance technology associate's degrees, one with a wind major and another with a solar major. Now, I had mentioned that we do have the education partnership that is a collaboration over 6 states of 11 different colleges and universities. And our website, which I'm going to give you each a card that you can visit, has a lot of good educational information about the fuel cell industry and about how the fuel cells work. So I'm going to kind of page through this because I've got a little simulation that I want to show you. So what I also want to show is that there are actually, a lot of people think the hydrogen economy is something way in the future. Truth is, there are hydrogen fuel cell buses already in operation and have been in operation for quite a long time. The challenge we have in Ohio is we don't have the infrastructure, but it will come. It will come.
Where are these available now?
These buses are already running in places like Washington State, Connecticut, California, Honda, Honda, Hyundai, and Toyota are commercializing their hydrogen vehicle in 2015. If we all know about commercialization and model years, that means they're actually going to be selling those cars in 2014. And believe it or not, those Hondas, some of them are going to be produced in Marysville, Ohio. So I think very soon we're going to be on that hydrogen byway. And I'm collaborating with SARDA to try to gain approval and support for building that hydrogen infrastructure. That question in the corner?
Yeah. So this new energy, it brings a lot of change, but one of the things that makes our economy so strong is that we have a lot of oil here. So how do you expect to prevent political pushback from those big groups that generate a lot of money from fossil fuels? Like how do you, I know there's a need, but money talks a lot in the United States.
Well, the good thing is that we've got the Department of Energy on our side. So Yes, you're right. Oil companies are gonna push back. It's their bread and butter. But they also realize that there are environmental issues, there are sustainability issues related to supply. So, for that reason, you're gonna see it moving forward. Is it gonna move forward more slowly because of the amount of gas that has been found? Absolutely. Absolutely. That'll slow down the deployment, but it won't stop it. So, a lot of people think fuel cells is a new technology. The truth is, it was actually invented way back or identified in the 1800s, late 1700s. And an actual fuel cell was built by Mr. Grove in the 1800s. And further developments by Mr. Mound in 1889. Now, what was holding it back? Cost and emissions from the early ones. And what pushed it forward? Beyond Mr. Bacon was space. We needed a means of reliably producing power, water, and so forth to support life as we went to the moon. So there was actually a fuel cell right there on board in the Apollo spacecraft that provided that, served that function in the spacecraft. Now, the difference is, again, technology was there, but the affordability of it at that time wasn't there yet. But we've learned a lot from the space program to make it cost effective so that it can be used on land as well as in space. So how does it work? Basically, you use hydrogen at the anode. We use a catalyst, we split the electrons from the hydrogen. The hydrogen becomes positively charged, as you see. It reaches the anode, or the cathode, merges with the oxygen, O2, and your exhaust is water. So you're producing or you're using the electrons to light the lights. You're basically borrowing the electrons from the hydrogen. And this is a very important concept because when you think about transmission of energy, you have a lot of transmission losses. So for example, if you have a wind farm in the middle of the farmland, you might not have the grid that goes there. And it costs millions of dollars to lay that infrastructure to then transmit that power. But you have another option. You can use that energy to produce the hydrogen through electrolysis and store the hydrogen and then transport the hydrogen. So that's another option.
And the only significant byproduct of
A
fuel
PEM,
cell?
of a PEM fuel cell, and I'm going to show you another one next. So this is the PEM technology. This technology works very well for portable systems. So the vehicles that are hydrogen powered are this kind of technology. The portable systems, the backpacks that the soldiers use, will be this kind of system because they're light and they're effective. But they're not very effective for major power. So for major power, we need a system that doesn't use hydrogen, but uses a combination of other gases or fuels. And the experiment that we're going to do over on the right is exactly this type of system. So the solid oxide fuel cell system is a different technology. So here, what is happening, and this is what the LG principle is that they're taking natural gas, they're synthesizing it, and then ultimately what is passing through the solid oxide fuel cell tubes is a combination of hydrogen and CO. And what you can see is you get many more electrons that way, and this is how you can get, you know, a megawatt scale of power in basically a footprint that's not longer than the length of these tables. So this is critical, and it's also extremely reliable and more efficient than other means of producing energy. There are also other types of fuel cells, and I'm not going to go into detail on those, but when I met with you last, I gave you a sheet from the Department of Energy, and I see, Jack, you have one there. And this has on the back the list of all of the different types of fuel cells. And on this then you'll see the ones that are appropriate to transportation and those that are for main power generation. So this is what our grid is going to look like a bit in the future. You're not going to have just one big central plant supplying all the energy. So instead, you're going to have combinations of photovoltaics, solar, and so forth. Now, this is why we're doing it. If you look at, you have 100% of the energy at the beginning of a coal-fired burning plant. You lose 65.5% in the generation itself, so, which means you've got 35% left. You lose another 4.8% in the transmission, got 30% left, and then when you step it down from those high power lines down to your house, you've got another 5.1% loss. So you end up with over 25% of the original potential. With a fuel cell, you're in the neighborhood. You don't have to have those high transmission lines. You get 60%. And to your socket, you get 55%. So this is why fuel cells are so important. Now I'm going to send these links separately that give you just more background. There's some nice simulations of the combination of solar and wind and so forth that you can look at here. And also there's some tremendous resources on all of those positions and career opportunities within the energy sector. They predict that within the next 10 years, 50% of the engineers in the utility industry and power sector are going to be retiring. So there's some great opportunities as you come out of college for that. And again, this is just more background that I'll share with you. So, is there time to do the experiment, or?
How much time do you need?
Would only take maybe 10 minutes.
10 minutes you have.
Okay. Okay. So if everybody'd like to get up, I'll grab a couple of lights and we'll do a little experiment.
Hey, how you doing, Mr. Creel?
Okay. Gonna need some of the setup people.
It's gonna move right around you guys. You could be with a group, so you separate. One of you go with one group, one would you go with the other, and you're just gonna watch. You're not gonna touch it. So you go with the groups, and you pick out who you want to sit with. Okay.
Well, this week I'm actually in town. I'm in town.
You come over here with me.
Hi, honey. You see what I'm doing right now? I'll pick a group for you. Okay. How about this? You just walk around. Let's put this down. Yeah. Okay. Just walk around and look.
So you can see how you're going to set yours up in a little water. We're going to start by filling up the vials to the 0 point with distilled water. Then, somebody wants to read this over to them. Okay, so pull up your vials and fill up your cups to the 0 point. Then what you're going to do is to take one of the domes and you're going to set it down in the water with a little notch that it's not covered by the little plastic half moons that are in the bottom of the, and you're gonna put the, if it's still connected to your fuel cell, you're gonna put the black side connected to the H2 and the red side connected to the O2. And again, you wanna make sure that that little cutout is not covered up by the little, I guess there'd be a little bit of quarter moon in the bottom of the cup. Okay. And then maybe somebody else on your team there could take your lamp and I'll run the cord down so you can actually flip your lamp on if it's mounted. You can actually use it, you can actually lean it on your bottom. Okay, so you got your water.
You're not gonna help me with it?
You good though? He's not a dumb. Did you guys go? Okay. Why? I thought it was expensive. Okay.
Two expensive things right now.
I know you're going to promote. I'm going to promote. Which one are you going to? I knew you were going to do that. I knew it, and I didn't react to that. How was it?
Are they supposed to be on opposite sides or no? That doesn't matter. Output, input, you had from the same size.
What are you looking for?
I didn't know if it came from opposite sides, like from input to the output.
Actually, you don't even need to use your monitor for now. But pull out your solar panel. Yeah. Use this, and then this is the stuff for your fuel cell. I guess so.
The one in.
It's going into politics, so don't worry.
Wow. Let's just check.
Yes, we need light. A red wire, so take your solar panel, take a red wire and a black wire, plug the red wire into the red notch and the black into the black, and then plug it into your circuit board. Again, red to red, black to black.
Enough far enough?
Okay. And then into your
Actually, let's just do that. There we go.
The red goes to the O2, so you know that.
You know that the black goes with black and the red.
The red goes with the red. It's not plugged. Oh, it is.
There.
How are the two systems? Yeah, like I don't understand.
That. Maybe they plug it right there.
There's more cords over here. Yeah, I think cords in there as well. I feel as though there's not a connection. Pick up another monitor. Are we gonna plug the wire? Yeah, we're gonna extend it. I don't think it will.
Let's
Nothing
put it right
connected
there.
to anything.
I assume the solar panel will make the battery work.
Let's just ignore the fuel cell.
Okay, you got a solar, okay. Yeah, so, okay, now, we're gonna want to actually set this up so that you're running electrolysis and you're lighting the lights at the same time. So, you wanna use your circuit board. You set that down, that's good. Okay, that's a lot. So what you're doing here is you would try to run your motor directly, but to be honest, it takes a lot of energy. You can see there's a lot of intensity. If we were outside, it would start like that, because the sun is so much more intense. But what I want you to do instead is to go ahead and
No, she has the light plugged in, not the
Hey, where's it going? We win.
Okay.
That's actually what happened with us.
That's because Mr. Miller disconnected us.
We win.
Yeah. We won science. Yeah.
Wait, you don't have a ribbon? Still going into politics, so I'm okay.
Yeah, there you go.
Why did the lights shut off?
It's a monitor.
It's just gonna go away now.
I don't know. Look,
I'm confused.
Take out the black ones.
It's got a red wire that's not
Well, let's turn this off.
a red wire.
How do you turn this off?
Probably. Yeah.
Save the good thing is.
I think you forgot to connect something. What happened? What are you talking about? We did win. We didn't win. We did win.
Then you create.
Oh, look. They're up and running over there.
Yes, ma'am.
Okay. So, what happened to us? So have you seen some changes going on?
No.
Oh, wait, you unplugged your light, why? We're not using the motor yet, because, oh, did you already get it to run from the
No,
hydrogen?
no.
Okay, then, okay. What we want to do first, and you don't, oh, here we have a problem. Yeah, it's not a series circuit, it's, you've got to have red to black, black to black. Yeah. Okay, wait.
Great, what happened? Great,
So
what
what we
happened?
want to do is, what we're doing is, we're actually using solar to light the lights, but we're also powering the electrolysis. So here, what we're doing is using the fuel cell as an electrolyzer.
Right.
So by putting energy in and putting water in, then we're running the process of the simulation on the screen in reverse. So what we're doing is we're storing then that hydrogen and the oxygen in the little cups that we have at the bottom. And we'll know if we made hydrogen if we turn off the light and the lights are still on. Now we also will know we've made, now what you'll find is if you try to plug the solar panel directly into this motor, you'll almost have to have the solar panel right on the light to get it to move. But yeah, but if you use the hydrogen, once you have enough, it'll power until it's out. And it'll be a consistent power until it's out. So the beauty of fuel cell technology is as soon as you have hydrogen or the fuel coming in, you get constant power out. So the unique difference between, exactly. So the unique difference is are built for primary power, not just intermittent power. So they're used in hospitals and different systems, but it's also part of their daily power.
So would you, Susie, would you take those two right there and plug it in there to see if through here it constantly powered or no? Oh, just right here, right here?
Oh, and you have to turn it too, that's great. The motor, yeah, and that's because you're running purely on the hydrogen. Now it's gonna run out, but now you can.
Wow.
There you go.
All right, and now.
Yeah, if you build up the hydrogen.
So we need more.
You got the idea.
Let's see.
So did it use up everything here then?
Yeah,
This little
LED
dome.
probably produces or requires a lot less energy than the fan does. LEDs are one of the last
I'm right behind you, Mark. Right behind you.
Oh, I get it. Look, the lights are still on. And then
This is building up.
science.
What? How much is that? Wow.
You just need to turn on the light.
Hydrogen's gone.
Very brief science.
Isn't it going the other direction now? No, I'm kidding.
Reverse that.
That'd be really funny.
Yeah, exactly, you know? That's right.
Gonna try it again?
Yeah, they actually put this in a box. They just look at these two.
Was she gonna do something with this, or this is just a model? I guess this is a model. I see red and black. I didn't know if it could be hooked in or... Can we try it and see? I'm try it.
I'm getting married.
Do you want to try to, right, connect? So we're disconnecting this, connect it out.
Where did this connect at?
Underneath the red.
I might be messing something up.
Well, we'll try it.
Our science.
That's right, we're experimenting.
And I think you push that clip to get it in there. Put the clip.
Oh, that was a safety.
There you go.
Watch your hand,
I don't know if that's enough power.
Like, I think in theory it works, but we didn't really power it.
Huh? Okay, everybody, we're gonna stop the experiment now, so go ahead and shut your lights off. Thanks. Thanks, Romero. And after the
This year. According to my sheets, and I'm going to have Mr. LaRocca, he couldn't be here today. I'm going to have him update this matrix next time. I'm going to have him update this matrix next time. But there's, at last count, there was 7 individuals in the Campbell group, seven students that had engineering as a primary career path, and then we had another 4 individuals for a total of 11 that were interested. How many of you are interested in engineering?
Secondary or primary?
Mr. Bruno, do I count you in?
Yes.
Raise them high, so I can see. Okay. I would encourage you, between Mr. LaRocca and between Ms. Shearer, I would encourage you all to use these meetings at the end of these sessions, grab a hold of them, and find out, you know, what else you can be doing. They are a wealth of knowledge in engineering. Networking is tremendous. One of the jobs we're looking for is with Stark County this year, with the Stark County engineer. So you should tap into that and take advantage of it, okay? And I will tell you that as we go around the colleges, right, Mr. Bruno, engineering is hot. They are dying for engineering students. There's scholarship money. They are rolling it out.
STEM grants, yep.
They are absolutely rolling it out. And in STEM, and believe me, there is enough exciting positions in engineering. I mean, the more I hear about them, there are wonderful, wonderful careers in engineering. So, and you're all bright, and you're all great in math, or maybe great isn't the word, right? Great. Not adequate. No, you're very talented individuals, very good in math. You excel in math, and it's a fine career. So I would encourage you to relook at it. Okay, let's talk about the last seminar, which I did not attend, but I understand it went very well. What did you think about the legal seminar that we had? Really liked it. Really liked it over here. Let me put it this way. What was the most surprising thing you found out during that session? Is there anything that was like, wow, I didn't know that?
the necessity of patent law,
Necessity of patent law.
and how Akron is a big leader in that. Patent laws, we talked about, is a really high market field, makes a lot of money, it's really being pined after. And Akron has one of the, Akron's law school is one of the leading in patent law.
Okay, that's a lot of us. Thank you.
That is really good, I guess, to get an undergrad in a science-based field. Because I always thought like lawyer, get a humanities kind of thing, and go to law school, but like they said like physics was a one kid, which was weird for me.
I'm sorry, go ahead.
Like a physics degree, they said, is a really good degree to get for your undergrad. Which I always thought like humanities for lawyers, public service.
Yeah.
But they said the science base is really good to get.
Mr. Demchak talked to me about that. I was kind of surprised. I was kind of surprised at that too, but it does make some sense. EJ, did you have something?
I was just gonna say the way that they talked about what everyone's view of a lawyer is, how that's not how 90% of the time it's not what you're doing, like the TV thing where you're there in the courtroom, they're in the courtroom in front of the jury. That's just, a lot of the times it's just not what it's like. It's not, although for some people it is, for a lot of people it's sitting in meeting rooms and boardrooms and researching and reading and trying to figure out the best way to present a case. And then you have the actual portion. Also, how much of law now, we talked about this for Goodyear, when a lot of businesses are now making you sign the agreements to settle out of court, and that's becoming more popular legal mediation, where you don't go to court, you don't go in front of a jury, you don't necessarily go in front of a jury.
Right. Right. It's probably one step towards tort reform, you're right. Anybody else? How about the format of the presentation?
Of the PowerPoint?
The presenters, how they conducted their session. I understand that was very acceptable. Yes?
I'll comment on that.
Yes.
I really liked it because they all sat in those high chairs up front.
They all sat
And
in
it
high
was,
chairs, right?
yeah, it was conversational. It was cool. I liked
It
it.
was
It was lawyery.
It was panel. It was like panel-esque. Like if you go, just
Panel-esque.
Yeah, they got to
It's
talk.
a great word. Is that a word?
Panel, like
Esque, panel-esque.
I don't know.
Can I use that?
That's
In Pictionary?
letting them talking, and then letting us ask questions and kind of have a back and forth.
Yeah.
Was
And a lot of their answers stemmed off each other's. They had different experiences with a lot of the questions.
Okay, well, based on what I heard about that, we bought 3 chairs that they were sitting on. So they'll be here in this meeting room, and we can use that as a format in the future, so good, I'm glad. Yeah, I heard it went over very well, and I'm glad, and I just want to do a little bit of reflection on that. Anybody else have anything? Yes?
I really liked how at the end, because I think a lot of us have opinions on
No, they don't have opinions.
stuff that's going on in this Snowden and everything else.
Right.
We got
Yeah.
a time at the end the public side and a group of us took the government side, and we kind of defended
That was
Fourth
great.
Amendment.
That was cool, huh?
Participation in that is.
Yeah, which was really cool. I really liked that.
Yes.
I like that too. I just didn't like the side that I was on. It just made me see how lawyers sometimes they get paid to go to what word do I want to use? I don't know. To
Defend
different cases they don't like.
Exactly. Yes, Cliff?
I had a problem with it though because, so the exercise is very interesting, but I feel like it could have been done better because for the entire presentation we were talking about how lawyers and how legislation are designed to protect human rights and the rights of the individual. And then we have a project where, we are split up into 2 different sides, the government and then people who are kind of not wanting the government to look at data and stuff. And it was kind of interesting to see how the entire presentation kind of went along the lines of, okay, we're protecting individual rights, now we're going to have an exercise in which we're kind of championing or kind of like helping out the individual right group. So I didn't like how the government group had to kind of like scrap and find a reason or an answer that would have either sounded really uber conservative or really uber radical. So I feel like it could have been more even, or less, or maybe they could have picked something else like a local situation, like say Ariel Castro with the whole Cleveland terrible thing that happened, to protect his rights even though he is a nut, or something a little bit more local. I didn't like the
You
example.
know, I was going to take credit for asking Mr. Demchak to give you that kind of example, but after hearing that, I won't take credit for it. I'll go back and tell him.
It's not, it was
No,
good.
I understand what you're saying. So you wanted like a point counter. You wanted maybe 2 exercises.
It could have been done
One
so
that-
much more evenly.
Okay, okay. I'm not sure they got that deep into it,
Yeah.
but I could understand where you might think that.
Yeah.
Okay, all right, good. Okay, now, not so good subject is the state of absences here in the camp seminars. We had kind of an increase, and Mr. Bruner and Ms. Sozowski and Mrs. Myers and I have decided that we are going to recommit to our rules and regulations, which is, again, a week before an absence, you must notify Mr. Bruno and Ms. Sozowski or myself that you will not be in attendance. If it is an emergency, we understand that, but you have to clearly communicate with somebody that's an emergency. And obviously, I had actually 2 or 3 calls this morning, and that's, so the issue is actually kind of exacerbating itself, and so it's not going to be acceptable. We will send out a warning for 1 unexcused absence, probation for 2 unexcused absence, and unfortunately, we have only had to do this once so far, a dismissal from the program on the 3rd. So please, please attend, but more importantly, this whole issue of communication. And I happen to be tracking for the last 3 seminars. I sit down a week or 2 before and I send out an invitation to the meetings. And I not only send it out to yourselves, I also send it to the operating committee. And then I painstakingly wait for your responses. And the last time we talked about the whole communication issue, I think you remember I had a little whiteboard here and I was talking about communication. I was relating it to the business community. And right after I did that, in the March seminar, 80% of you responded to my invitation for the meeting. On April the 6th, 50% of you responded, and most recently, less than 45% of you responded to this meeting. And I sent that email out 2 weeks ago. So I guess what I would say is, we love treating you like grown-ups. I mean, and by the way, your feedback to how we conduct these sessions, asking you to wear business attire, asking you to be on time, having place cards and things like that. Your feedback, your original feedback about 6 months ago was, I love this. You're treated like adults. Okay, if you want to be treated like adults, I can tell you that if you're going to only respond to 50% of the communication for the program, or you are going to do those kinds of things on absences or be late or whatever, then that's not very acting like adults. So in a business world, I'm going to take it right back to the business world. What this starts to question is your reliability, whether you're responsible or not, responsibility, whether you have commitment or personal accountability. And I'm not going to do anything except the next part of what I was going to talk about was we have 10 to 12 apprenticeships that we're looking at right now. And I'll tell you, when we sit down as an operating committee, and again, there's 14 to 16 people on the operating committee, and I sit with Mr. Bruner and Ms. Sosowski, We have a list of all the candidates that want jobs, and we're trying to fit people into jobs. We are desperately looking for the right jobs for the right people. You will not be one of the right people if your communication skills are not there. I don't, it's not a threat, it's just the reality of it. It's just, I have to make sure that if an employer wants to get in touch with you, or you are gonna accept a position with someone in the Goodyear organization, or the Timken organization, or Freshmark, or Habitat for Humanity, or Howard Hanna, or it just goes on and on. I have to make sure that you have these communication skills. We're not trying to do anything other than to impress upon you that this is how you act in a professional manner. So, I hope I don't have to talk about this again. It's not the most pleasant of conversations, obviously, but the good news is you all have time to make a difference and turn it around. And, you know, I have, some of you have not answered 3 meeting notices, some of you answered 1, some of you answered 2, and it's kind of, be cognizant that there are people taking the time to care about you and getting you ready for out there, whether it's now, next year, the year after, or the year after that. And by the way, nice to see you, Zach, and Alec, and Kaylee, our graduates. Nice to see you guys.
Hello.
Really, it's really good to stand up here and see you guys in the audience. Rihanna was trying to get here today, and it didn't work out. But anyway, that's 4 out of 5. Those are good percentages. So anyway, any questions about what I just said as far as communications is concerned?
I have a question, Seth.
Yes.
Through what format are we receiving the invitations?
I send you an Outlook.
Okay.
I send you an out. It's right in Outlook.
Okay.
Outlook calendar, and it was interesting. This is the first time I sent it out 2 weeks in advance. I did because I was in Charleston last week. We were away, Mrs. D, you know. And it was the first time I sent it 2 weeks. Usually I send it a week before. And it was interesting to watch the flow. I actually got 2 or 3 this morning, which is okay. But I asked, in this program, you're gonna need to be checking minimally once a week, if not every couple of days. Okay, checking your communications and your emails. Any other questions? Okay, profiles. Unless I'm mistaken, you can tell me right now, profiles. I am still looking for Jaquan's. Where are you, Jaquan? Jaquan, I'm still looking for your profile. Daniel, do I have yours? Do I have your profile? Okay, would you guys send them to me in an email, please? Coulter, do I have your final profile? Would you send it to me again? Mrs. Zosky may have it and I may not have it, so if you would send it to me. Miles, do I have your profile?
Yeah.
Could you resend it to me, please? Okay. And Jared's not here. Okay. So if you would do that. The point I'm at the profiles is everyone that we're looking for employment and seniors. I'll be through those now, and many juniors I'm through, and believe me, I will get to the rest of you over the summer, and we will do it. I have to tell you, the feedback on the profiles is terrific. Some people have said that, you know, they're pretty sure that it's made a difference in looking for a job and employment. Yes, Gray.
I just wanted to mention that I used my profiles to get into Boys State this summer, so
right.
That was.
Gray used it to get into Boys State, which is an organization for actually within the legal field, correct? And he is convinced that it helped him. So once again, we're doing this to help you out. We know this is something that you can use and you're going to need in the future. Who here is in Model UN this year? This year, Model UN. Okay, So we're going to be getting to you. Mr. Slifer, raise your hand, Mr. Slifer. There's Mr. Slifer. He is going to be heading up with Berkeley College, and I believe Ms. Turner and who else, Ken, is on Model UN?
Ms. Turner so far. Mr. Foltz is kind of holding off a little bit unless you guys can convince him.
We did, well,
We did.
He wanted to take a little break from
he said
something.
he was coming back.
Everybody piled right on.
Okay, so Mr. Sipek and Mr. Slifer, Mr. Sipek has agreed that he's going to help us, and he's going to help us help you, and we are going to be, we'll be getting back to you on a couple initiatives to raise some funds for Model UN, okay? Because we think you have a real struggle, and last year was a struggle for you, so we'll be getting back to you, but that's good news, that's on its way. Okay, with that, I am going to turn it over to two of your distinguished classmates. How's that? This is great. We've been working on this project for about 4 months. This is your website. I have been there simply from what do you need, you know, whether it's pay a small bill to get the internet, the web up, or the internet up, or I don't know, coffee and donuts, whatever they needed, I was there to support them. Getting them a drink of water when they needed, no, I'm just kidding. But they worked extremely hard. Summer got tied up, she was on her way, she still even may come in, but this website is terrific. This is your website, and they need some things from you, and I hope you help them out, because they will be moving on. I mean, they'll be the next Kaylee and Zach and Alec, okay, out the door, and you're going to own the website. And this website is key as we go forward. Okay, so Hannah and Matt, go. All of that time and you're not ready? I said go.
He wants to sit.
Oh, he's got to be comfortable. I'm sorry.
Of course. All right. You ready? Can we like a countdown or something? I feel like.
Okay, James is gonna do it. 3, 2, 1. Watch it not work.
Right.
It's pretty.
All right, so this is the long time coming camp website. The address or whatever for it is echscamp.com, so it's pretty easy to remember. And then this is our homepage.
Oh, okay, so I guess that was supposed to talk. Across that green bar, you see the scrolling words. It says next camp meeting June 2014.
That's all one.
And yeah, so if by chance we have a cancellation of a meeting, or there's a reason, or something that you guys need to know, that's where you'll find that. Like last time when there was weather, we needed to cancel the meeting, and it was difficult reaching people. So if you're not sure we're going to have a meeting or not, just hop on the website, check that out. Across the top, yeah, Hannah's flipping through some of the pictures. Those pictures will, whoa, change it. Those pictures, Hannah, those pictures will change as time goes on and we get more pictures of you guys. Across the top, you see our story, our philosophy, our students, and get in touch. The first one, our story, is just kind of a little background on us, on early college. Yeah, sure. And it actually, across the top, you see the toolbar. It takes you to the About Us page. And there's a little bio of what camp is, what early college is. And then we have a link that'll take you to the courses that all early college students take. The Associates of Arts and Associate of Science degrees, those 2 tracks. You can also go to our philosophy, which is kind of just what camp is about, what we believe. There's a quote, professionalism is a frame of mind, not a paycheck. Again, a short little bio on that. You guys can read on your own time. Time for that. And then we have links to the operating committee. And here we have pictures of members, and a
bio next to their name. So if anyone asks you, what's camp? Like, who is involved in camp? You can bring them to the website, show them really the leaders of camp and what they do, why they're qualified to help us out. And then we have the bio of the students. So far we just have a quick little bio for Zach. And we have pictures of others. So right now we just have the class of 2013 and the class of 2014. Eventually the rest of you guys, I guess we'll put on there. Once we get pictures and whatever. And then here is really the meat of the site, career paths. This is where you can come to explore different career paths, different options as you pursue education. And we have it's split up into 5 main categories: arts and humanities, business, health and medicine, public and social services, and STEM.
I'm working on it.
You go to the arts and humanities page. We only have, okay. On each page you'll see there'll be a box that says careers, one that says resources, and one that says elaborate. The careers box is essentially going to take you through different careers that you could get with an education in the arts or an education in business. And then the resources, you can look there, click on those articles. You want to try one? Those are actually articles that will take you to the website of either, I don't know, Canton Rep's website or Monster, or yeah, lots of different websites, lots of different resources that you guys can find there. And
Should I keep going or just go away?
So Matt, if there's an article we want posted up there, how do we go about doing
if
that?
you want to post an article, I mean, just contact one of us right now. As we pass on the duties to future members of the website team, they'll be responsible for that. So, and then attending meetings is critical for the website because just now when Ms. Shearer, when she had those links on, so later on I'll go post those on the website so that you guys can go there to access the links that she had for her presentation. And so each site has a little different theme. Okay, we can, no, you can stay here. And then this is a box for people outside of camp who may not know a lot of details about the program and what we do or what it's all about. What they can do is type in their name, their email address, and whatever question they might have, or if they want to make a comment. And that'll go directly to Mr. Venturello right now.
No, it goes directly to...
Oh, never mind, I lied. It goes to, we created a camp email address, and I go to that, and whoever needs to see the question will see the question, and that person will get a response. So if parents want to, what's that?
Is there more contact information going to be put on the board of directors?
For the outcome, yeah. I mean, yeah, as we get that, it'll be posted, yeah. If you guys have questions about anything, just say,
There's a question.
Jada has a question.
Jada has a question.
How do we get on board with YouTube to help out?
Awesome question. We'll get to that. Good. You're awesome. All right. Actually, we made a job, and when we were writing out the job title, right? I got it. All right.
The best page on the website.
Best page on the website. Skilled camp. So. Oh. Okay, so you guys know about there's another. Okay, just move on. It's for a future website for a sister program. Okay. I don't know. Okay, and then here are the student resources.
Do you want to spend 10 seconds, Mr. Bruno, to tell them about the Skilled Camp and what we're trying to do?
Yeah.
If you wouldn't mind.
Sure. Skilled Camp is technical camp.
Technical camp.
Technical camp. And the idea behind it is to work, and I think I've been advertising this inside of the lunchroom, and we have a team teacher that's working with Ms. Myers, and it's Mr. Longenecker. He's the one that's the high school connection that is helping to spearhead this to start it up. We're looking at 10 to 12 members to be a part of it. We're working with 10th graders up to 12th grade. The requirements for getting in is not as stringent as the ones here. We have a 3.0. This one is a 2.2 GPA. A strong interest in the engineering field, computer-related field, mathematics field. Any of those students that would like to get into one of those sort of skilled areas to go ahead and work and find out more information about it, this is for them. And we did have a couple of students from here that were actually interested in that. But it is supposed to work in conjunction with this program. They will be meeting once a month. There will be some times where there's a joint program where it's an interest of all students that will all meet together. But most of those meetings are going to be separate because some of the things that they are going to be talking about is going to be specific to them as opposed to what we have with you. So we have taken in some applications. The deadline for it was just this past week. We're going to be looking through those and bringing those students on board. So it's going to be very similar to this, but it's going to be targeted toward the mathematical, engineering, and computer-related fields for those kids that are interested in, students that are interested in.
So that's what that last page will be. It'll just basically be a quick bio to that program, and then a link to their website. They're going to have a separate website. You see Hannah logging in. Everybody today, you guys are going to make logins for the website. And there's a section of the website that has more sensitive information about each of us, so like our bios or whatever, and more camp meeting dates and places and times. And so you guys are all going to make a login today. Yeah, we'll figure that out. And so the first thing you see when you get to that page, once you log in, you see a calendar of events. So not only will it be a calendar with our meeting dates, it'll also have volunteer opportunities, graduations, anything, any important dates that students are going to need to know.
Tom, do you have access into this? Can you update this yourself too? Or do we have to go through Matt and Hannah and the group?
I have access to it, but the updates are going to be through the website team, yeah. So for the next month or two, it'll still be Matt and Hannah, and then they'll be bringing on board, Matt's going to get to that in a minute, some other help.
Okay.
So.
All right, and then we have the speaker bios. So here, the names are linked to the bios that we hand out that they hand out for each speaker. It's there. You can just you can go in, click on it, find it. If you lost paper, print it out. Do what you have to do. So just another resource for you. Seminar handouts, same thing. So if you forget what the dress code is, or want to see the wheel of Hannah, or Hannah's signature, then you can hop on the website and access that right there on the website.
It won't go up.
Homework. So this is awesome. So when you leave here with that paper and then it's getting a couple days before the meeting and you can't find it, hop on there and print it out, and then you can have it done for the meeting, whatever the assignment might be.
We don't get it every time.
No, not every time.
No.
Not every time, but
like the boxing where we have to
yeah.
Yeah.
So that'll be up there. And then, okay, so this is a topic in itself. The videos. As you guys know, Mr. Bruner, he always records us. Is he recording right now?
Yeah.
Awesome.
Yeah.
So Mr. Bruner always records, and so we have all those videos on file. We need someone who knows what they're doing, because it wasn't me. And in the future, all those videos will be accessible. We have a couple of them, on file, but they need cleaned up. So that's one of the jobs. You guys just think about who might want to do that. And then scholarships, we're gonna have a section for scholarships as well. We want, what's that?
Just go ahead.
I mean, if you want to talk. We were gonna put those originally on the part of the website that's unlocked. But then we thought about it, like, if there's scholarships, we want to be competitive in getting those scholarships, so maybe don't release them to everyone, keep those in the family. And, I mean, that's pretty much it.
All right.
If Hannah has anything to add. All right, so we're gonna move on to like the different.
Question over here.
Oh, I just wanna, I
Wow,
saw
you
something
were
about
with us
DHOF
when we made it.
realtors on the website, and I hope you know that that's not Howard Hanna. What? What did she say?
Thank you. Yes, Megan.
And
She's saying that you have to be very careful of competitive activity, is what she's saying.
what?
I'm still really
You had something
All right.
about, no.
You had something on that, you were going through with DHOF
You had
Realty.
something on there about DHOF realtors.
Okay, yeah.
And I hope you know that that's not Howard Hanna.
I hope you know there are other realtors.
I hope you know Hannah. You should be hoping those other ones.
I got it.
And they came by crazy. And DHOF is not that realtor.
It took me so long. All right.
Anyway.
So these.
Good job,
Okay.
Megan,
Oh,
I like that. Way to go, Meg.
All right. So. There's no problem. You're gonna have
I'm
to
just,
share.
can we go ahead and talk?
Yeah. Go ahead and talk.
Okay, so as we were going through this, because we are leaving, we kind of broke down all the jobs that would make updating, tweaking things on the website pretty easy. If this is like the goal number of people, you don't typically have to have as many people, but this makes it easiest. So there needs to be an IT historian. They'd be responsible for uploading the videos. We're not gifted with
We're not able.
editing the camp videos, taking pictures, everything that kind of goes along with digital media. There's going to need to be about 3 editors, maybe 4. We can put the 4th one on here. There needs to be about 2 general co-editors that just goes through the site, make sure everything is working good.
Right, and then those paragraphs that you saw about what camp is or whatever, those are the people who would be responsible for the majority of that text, things like that.
There needs to be a student section editor, which just works with the camp student section. That's pretty low maintenance, I guess. You need that they would be in charge of uploading the handouts, uploading the student bios, or the speaker bios, and updating the calendar, among other things. There needs to be, oh, and then the 4th editor would be the mobile editor, because we have a mobile site. What we use, it can have a mobile site, but right now, it doesn't really work well for phones. I mean, it works, but it could be better.
Right.
So there might need to be a 4th mobile editor. We don't know if that's a full-time job, so we didn't really put it on there. There needs to be a project manager, which is just like the overseer, enforcing, making sure things run smoothly. There needs to be a design lead, Jada.
Yeah, that was,
or other people, I don't know.
right, whoever else.
That, make sure it's aesthetically pleasing, make sure the colors go together, make sure everything kind of fits in with each other, so it's not all one theme and then another theme. And an information architect, which uploads pretty much everything else that the camp, or the student section editor and the IT historian don't upload. They need to be in charge of that.
Right, so that last one, like I said earlier, I mentioned earlier, someone would be uploading articles that from other speakers, or that Mr. Venturella finds, or that other teachers find, or that you find yourself in exploring. You would upload those links to the website.
And Matt, I'm gonna ask this weird. The filter for anything that goes on there, all that information has to go through Mr. Venturella or Ms. Lusarski, correct?
Right.
Before it's like, to get it the okay and stuff, so I'm not just putting things there.
Right, for sure. You got whoever is on the team. You're going to work with other teachers, work with other adults, obviously, because there is potentially sensitive information that we don't want to put out there, and information that we don't want to put on there that reflects poorly on the group. So, yeah, definitely.
Right, confidentiality, there's 2 prongs to it. There's definitely, this is a place where Mr. Bruner and I, or anybody can say, hey, Malone University or Walsh, here's the website, you can go on and look at camp. Or Mr. Sipek is having a discussion, I'm making this up, with the owner of Javasi, and he says, yeah, here's the website for camp, you can go on and take a look. And then there's another part of this, which is, what are we using it for, our working part of the website, and keeping in mind that confidentiality is number 1. That's one of the reasons we decided right not to publish the profiles and things like that.
Right.
The team thought, hey, you know, that's not right, we'll publish them, we'll give them to prospective employees or whoever on an as-needed basis. So just things like that. There has to be a filter, I guess is the point.
Also, just a general note about how the team operates. Currently, we meet weekly. You don't have to meet weekly. We were setting up the website, but you might want to meet weekly just to begin with. And also, every week we send out an email to Mr. Venturella, Mr. Bruner, Mrs. Zarsky, and then everyone else on the team. One person usually does it. That could be the project manager. It could be anyone who decided at the meeting to send an email. So there is that sort of thing where you do have to send out emails and updates.
So this year, last year we had 5 graduates. This year we'll have another 10, I believe. So we're going to be at like 15 camp graduates. This website, we are going to make a point of keeping in touch with our graduates. We have to know what's going on. We have to know, is everything okay? We have to know that if you're going to get a job at Timken or Goodyear or Habitat or Howard Hanna in the future, or you're going to return to a job, we have to make sure that everything's still in good standing. We also have learned that the liaisons that we put in for work would also be a fantastic idea to do for all seniors. So the operating committee is going to be talking about that this afternoon, so that you have somebody that you can talk to as you go off to college. So this website, we're going to be asking you to look at the seminars because you're still in camp, and you can be 1,000 miles away with this website, still look at a seminar. We'll probably ask you 2 or 3 reflection questions to make sure that you're going to answer them. We probably will be asking you for transcripts in the future when they're available, so that we know you're still in good standing scholastically, and things like that. So this website will be a conduit for all the graduates too. Okay?
Oh, okay. So right now, I guess we're gonna start sign-ups for the website. So we're gonna kind of break up. So if you are interested in becoming a part of the website team, just come up to me, talk to me, and we can talk about what job you want to do. If not, then just go ahead over to Anna, and we're gonna get you. We have a couple laptops and my phone, and we're gonna sign you guys up for.
What, you want to do this orderly, or you're just going to have everybody go?
Start at the front.
Okay. First row.
Well, you guys are doing that. That's what asked Merck Store, who might be part of junior cast, but we're doing the Mother's Day fashion show at the Senior Citizens Friday. We've used a couple of volunteers to help decorate and or kind of assemble bouquets on Thursday afternoon.
Ms. Lusarski said that she asked me, could she go ahead and do that again? That's going to require getting coverage for her and whatnot. I told her, sure, no problem. So I know that she was looking to get...
Friday morning.
Oh, Friday morning.
Friday morning.
Okay.
If anybody's available Thursday afternoon for an hour to come over to the senior center, just hanging up some decorations and putting together some bouquets for the seniors and some goodie bags. So
Okay.
we welcome your help.